The following content is provided under a Creative Commons license. Your support will help MIT OpenCourseware continue to offer high-quality educational resources for free. To make a donation or view additional materials from hundreds of MIT courses, visit MIT OpenCourseware at ocw.mit.edu.
Okay, so I get to do the introduction spiel for today's class. I'm going to start by just saying what we're doing in class today, so you've got sort of a framework of what we're doing, because we're doing a whole lot of things, and we're going to be jumping between speakers and workshops and lectures and in-class work. So we actually have a lot of stuff to try and get through today to get you guys started on Project 1. So we're going to introduce Project 1, and that's actually what my brief lecture is going to be after I get done with the class spiel. We're going to hear lectures on how to do brainstorming, and then we'll ask you to brainstorm. We're going to do lectures on prototyping, and then I'm going to give a more pointed lecture on what we mean by low-fidelity prototype, which is what Project 1 calls for. And we are going to do all those bits of in-class work, hopefully scattered along the way. Okay, so moving on to introducing Project 1 so that you've got, and the reason we're introducing Project 1 before we give the supporting lectures is so you've got something to frame. You're going to be hearing lectures about prototyping and brainstorming, which we want you to do for Project 1. We want you to be thinking about the project as we give you the lecture, so you can try and figure out how you're going to be applying that information to the thing we're going to be asking you to doing. Okay? So the overall goal is, and I have to actually stand back because I can either see my notes or I can see the slides, but I can't see both. So demonstrate a working mechanic via a low-fidelity paper prototype to serve as the prototype for a digital game while tracking and understanding how your game design changes over time. Any words there you didn't understand? Because we've got a lot of jargon actually up there, a lot of game design jargon up there. Okay.
What exactly is a mechanic?
A mechanic? That's actually a really good question. A mechanic is usually a key chunk of a game by which the player takes actions in the game or the game takes actions. So if you're playing like a basic platforming digital game, one of your basic mechanics is your character can jump. And that's what your character often uses to solve a lot of problems. A very common mechanic in games is shooting. So a mechanic is basically an in-game action. It's a game design term for that. Any other questions? Okay then. So we're hoping that this project will teach you to do prototyping, which is a skill we will hope you will use again in projects 3 and 4, and we expect you to. And we're also going to introduce our very first project management tool, which is the design change log, which is hopefully a reasonably quick and concise way to record the changes your team makes to your design as your design evolves, and helps you keep a kind of a group memory of what you've done, so you don't end up doing the same things again. But that's not actually all we're hoping to do. That's just the official goals. We're also using it to give you a small group experience working in teams on a creative project. This is the first and last time you'll be in nice, small, tight teams of 3 people. Project 2, we boost you all the way up to 6 people, and by the end, we're going to be in 8-person teams. And you're going to get to see just how more complex it gets working with bigger and bigger groups. But we're going to start you we're going to start you small for your first project, so you get a chance to learn how to communicate. We're going to teach brainstorming. We're going to expect you to brainstorm again for projects 3 and 4, although we're not going to formally tell you where to do it or when to do it. We're just going to expect you, when you form your groups, to start going over ideas, to use the techniques we've taught you in this project to do that on your own. We're also going to teach you, and I think the most important thing here is working fast. You got 1 week to do this project, the final version, and your project reports on this are due next Monday. You're going to get some time in class, but unfortunately we have a lot to say to teach you everything you want to do with this class, so you're not going to get all of class. You're going to get a small portion of class Monday and Wednesday. And we're going to expect to be able to play something on Wednesday in class. When we're looking, hopefully you'll be running play tests. We expect you to have something working. So you're going to have to learn how to work fast. How do you get those ideas out of your head onto paper and usable quickly? And finally, the prototypes you're using here are going to move on to Project 2. Probably about half of them. Your team sizes are going to be shrinking, so we'll be doing fewer of them. We, the instructors, are going to take a look at the prototypes as they come in, both during the presentations and during the playable playtesting sessions, and we're going to decide which of those projects we think really do have the potential to go on to be Project 2. If your prototype isn't chosen to go on, that doesn't mean it's not a good prototype. We may choose to exclude things because we think the scope is too big for a 2-week project. We think it's a little too complicated to try and communicate the ideas. We may also think that there are other projects that sort of nailed the requirements better. So your prototype hasn't failed if it doesn't move on. It's just that there were other ones that we think fit all the constraints better. And all the prototypes are important to do. All right, so that's that. Okay, so the breakdown of the project is today we'll be forming teams, doing brainstorming and getting started working on things. We will do the first formal playtesting session on Wednesday. Monday, everything gets turned in, and including your changelog and a presentation. The vision document we will be making in class, so don't worry about that, because we'll be explaining what a vision document is and how you make one in class. So don't worry too much about that particular requirement. The presentation, the 1-minute pitch, will be one of the things that helps sell your classmates on joining your team, and will be one of the things that we use to decide whether or not we think you guys have a good enough core idea and enough core excitement to move that prototype forward. So it's actually pretty important. And remember, it needs to be 1 minute. We're going to have like 10 groups up pitching. So it's going to have to be fast. Finally, design change logs, which some of you may never have heard about. Whoa, oh no, my slide, it isn't there.
Oh, because that screen's been
because
up
this one isn't, aha, oh boy.
Let me restart this presentation.
So who here has used a design changelog before? Because if you've taken 608, I know you have. All right, so those are your experts. If you have one of those people on your team, you're in good shape. Talk to them. But essentially what a design changelog is, it's actually really simple. It's 3 tables. It's a column, it's a table, 3 rows, 3 columns. You got a date, you've got some action you made on your design to change it in some way, and then you've got the reason why you made the change. And every time you make a significant change to your project, and every day you work on your project, you make another entry so that your team and the people working on it and the people looking at your project to see where it is now can see why you made the decisions you made and what decisions you made. What features you dropped, what features you added, what problems you were trying to solve when you made those changes. Yeah, I was probably, anyway. So that is, in fact, a design changelog. There's an example of one at the bottom of the problem 1 handout there's an example of one at the project 1 handout, so you can see an example there. Are there any questions? Hearing no takers, I hand you over to Philip for brainstorming.
Okay. All right, let's talk about brainstorming. How many of you have done brainstorming in any class? High school, before high school? Wow, okay, all right. Okay, so it's a term that gets bandied around a lot. Let me see, awesome. However, there is a problem with brainstorming in that a lot of people have practiced it without actually knowing why certain things are done in a certain way, and as a result of that may actually be doing it incorrectly. We have an excerpt of an article, a chapter from a book called Applied Imagination, which is written by Alex Osborne, who is the guy who actually came up with the term brainstorming and the practice of it. He worked in advertising, and he has lamented since he wrote that book that a lot of people kind of liked the output of brainstorming, but didn't really understand the practice of it. So I'm going to try to sort of start from first principles so that you understand why brainstorming is and how it's supposed to be working, and then hopefully you can sort of get the benefits of it without maybe say overstating is power. Now, the main reason why we're doing brainstorming in groups, you will hear people out there in the game industry saying that brainstorming is not necessarily always the best way to be able to come up with an idea for a game. However, in this class in particular, and in a lot of video game design outside of this class, game design is coordinated, creative collaboration involving different skilled workers. And if this is going to be the first time that you're going to work with a team, you need to sort of understand who are the people who you might be working with. Brainstorming, if nothing else, can be a really, really good way to just be able to get a sense of who it is that you're going to be working with. And when we start forming up teams, you're not going to necessarily be able to choose who you're brainstorming with. So you want to be able to get a quick read of their ideas and what their interests are, and maybe decide, hey, this is the person that I'm going to do project 1 with later on. However, there are very strong social pressures of being imaginative in a collaborative environment, especially here in MIT. There's a lot of pressure to sort of like hold back your ideas, or maybe not say what's coming to your mind because you think that's kind of dumb, but other people are going to think that I'm stupid or anything like that. And brainstorming has certain practices to be able to get you past that. So there are 4 principles of brainstorming. This is High Templar just doing this thing. This was the 4 principles laid out by Alex Osborne. And he was an advertising manager at BBDO, which is a very, very large advertising agency. And there are certain similarities in ad marketing and video game design, right? You can produce ads, you can produce marketing, you can produce games without necessarily saying, yes, we solved the problem. There's a lot of different solutions for exactly the same problem, and advertising is trying to get people to pay attention to the ad and maybe buy stuff. In video games, it's trying to create an entertaining experience for somebody else. Millions of ways to be able to accomplish that. So we're not looking for like, here's a engineering solution to an engineering problem where there's if the thing doesn't explode, you've done a good job. That's a sort of like very easy metric to be able to measure success. For games, for advertising, not so easy. So here's the first principle. No criticism. How many of you been in a brainstorm session where like you said your idea and then somebody said, oh, yeah, okay, all right, I see some hands go up, all right, okay. So this is the most important rule of a brainstorm session. If you do not stick to this rule, if everybody around the group doesn't stick to this rule, you can ruin the entire session. The whole session can just become worthless. Basically, you can give positive feedback. It says like, thanks for the idea. Just simply writing it down is positive feedback of we've received your idea. But you want to hold back on sort of adverse judgment or any kind of negative reinforcement. You can share that after the brainstorm session. You just don't want to do that during the brainstorm session because it inhibits the process of creating new ideas. Again, that's a sort of like professional shame, and it's especially in a place here like MIT, but also if you go out into the corporate world, this idea of you don't want to look bad. And you can't have that in your head to have a proper brainstorming session. If you're worried about how your ideas are going to be taken, then you're not actually generating ideas at the speed that you need to be. So you need to be able to let your entire group know that we now have total freedom to explore all territories. Whatever idea you generate, we're going to write down, and then we'll figure out which are the good ideas after we've generated all of these ideas. Secondly, you kind of want to be freewheeling. Typically, the crazier the idea, the better. It's easier to be able to tame down a crazy idea than to sort of take a fairly unambitious idea and scale it up. So typically, you will get your best ideas from some sort of pipe dream or blue moon idea, something that's out of scope, something that's unfeasible, and then you sort of scale it down into the thing that is actually feasible. So go ahead and shoot for the moon. Shoot for the game that you can't possibly develop in the next week or in the next couple of weeks. And then after the brainstorming session, figure out how you're going to be like how you're going to pare down that idea into something that you can do in a week or in 2 weeks. Now, you can expand on simple ideas. And I'll talk a little bit about some strategies on doing that. But usually reworking a wild idea to become feasible, there's usually a nugget there that's a lot easier to identify when you start big and then shrink down. What are you going for? You're trying to come up with as many ideas as possible, quantity. The greater number of ideas, the more likelihood that some of those ideas are actually going to be useful. You are not actually trying to solve the problem in brainstorming. Say, if the problem that we're asking you to solve is create something playable in a week, we're not asking you to solve that problem during the brainstorm session. That comes after the brainstorm session. That comes with things like prototyping, which we'll get to later today. So the more, now that's a simple metric that you can use to gauge the success of a brainstorm session. How many ideas that you generate, at what pace that are you generating them at. Again, that's why you don't want to be judging ideas while they're being generated. All ideas should be included, nothing is excluded. And you're going to need to reinforce that within the group of people that you're brainstorming with. There's somebody who's actually got a job to specifically do that, but you've got to help with that. And you can build on ideas. You can refer back to ideas that have already been mentioned, taken notes of, and then combine them with your own idea, or even have ideas that other people have come up with to be able to come up with something sort of synthetically more complex. Great ideas are often generated when disparate ideas are combined. Lego plus Star Wars equals Lego Star Wars, which is awesome. Marvel plus Capcom, Marvel versus Capcom. Okay, great ideas there. And often that's actually where a lot of your really good ideas are going to come from, because you're going to come up with a whole bunch of really mundane things that basically refer back to games that you've already played, or ideas that a lot of people have encountered, but maybe not encountered together in the same context. So this is how you're going to do it. You're going to start off with a really try to create a little, casual spirit. This is not like a really straight-laced formal affair. Start with giving your worst idea. The worst idea that you can possibly think of. The most useless, terrible, if you have to do offensive, sure, but usually that's just an idea that is dumb. Just tell people that. Everyone put it down, write it down. While someone is speaking, don't interrupt them. But do designate a facilitator at the beginning of the session, and it's going to be that person's job to keep things moving. So you don't really need to explain so much, because, again, you're not trying to solve the problem here. You're just trying to be able to get enough ideas out so that whoever's performing the role of the secretary can write it down. And again, before you start the entire session, make sure everybody understands this process. If there's somebody who walked in late in a class or something and is just joining your team, make sure they understand all of these rules, these 4 rules that I went through. And write down everything. Now, don't just write down the title of the idea. Turtle tower defense. I don't know. Those are 3 easy words to write down, but it might be difficult for you to then remember exactly what that idea. Were they like anthropomorphic turtles? Are the turtles the towers? Are the turtles marching into towers? It's like, what was that again? Let whoever's taking down notes take a little bit more information, maybe like a line of information, just so that when you come back to that idea, you don't look at a title as that looks like a. What was that idea again? Does anybody remember what his idea was? That you just take the time to be able to write things down. Now, this is more general. Today we're asking you very specifically to brainstorm about the game that you're going to be prototyping for Project 1. But in general, you can apply brainstorming to a bunch of different ideas, even in the middle of a project, Project 1 or later, or to other domains. But it's very, very important to be able to know what kinds of problems are good for brainstorming and what kinds of problems are terrible for brainstorming. You need to be able to find a problem that is very clearly defined. The problem should be simple. If you've got a problem that's really, really complex with lots of very different opposing factors that you have to be take into account to optimize something, you can either try to divide that into complex, those complex problems into subdivisions where each one of those subdivisions could have a separate answer, or you could try to use a different problem-solving strategy entirely. You don't necessarily need to apply brainstorming to everything. You should be able to articulate the problem simply and clearly. But just because I can articulate the problem doesn't necessarily mean that it's appropriate for brainstorming. Osborne, for instance, gives you an example of get married. That's your problem, right? Okay, and then you're trying to solve that. Brainstorming is a really terrible technique for that. Here are all the ways that you can get married. It's like, that doesn't help. Maybe that doesn't identify the problem in the first place. It's a complex problem that's a little bit too large. What's your game going to be about? Or what is your player going to do 80% of the time? What's the one action that your player is going to do 80% of the time? Where is our game set? Who is our main character? These are sort of well-articulated problems that brainstorming does work for. Now, responsibilities, again, I said designate someone to be a facilitator, and this person's job is to basically keep this whole session moving. We don't like to use the word leader because your job is not to be the head of the brainstorming session. Your job is to facilitate it, is to sort of be the clerical equivalent of moving the process along. So you need to understand the problem, and then make sure that everybody around the brainstorm group also understands this problem. And then when the session actually goes, every time you sort of sense that there's some criticism coming out, and you say, all right, we'll put that aside, move on to the next idea. Try to diffuse any criticism when you see it coming. And encourage people who aren't speaking up to speak up. Just simply what's on your mind, or call out someone's name and just say, any of these things give you any ideas. Try to sort of call out those people who aren't already very much involved in the process to try to get them into the process. Because the more people riff off each other, the more ideas you're going to be able to generate. Encourage people to join ideas together. Sometimes you just do that yourself. You just look at two random things that you wrote down and just try to slam them together just to get the process started. And maybe other people will do more logical compositions. Make sure that no voices are lost in this process. It's not your job to identify, it's not the facilitator's job, by the way, to identify what's the best solution on the board or on the computer when you're taking down these ideas. That's not that may not actually be the job of brainstorming at all. That's actually a problem that you come to later when you see the whole pile of ideas that you generated, and now you figure out what it is that you're going to choose for, say, project one. Now there's a second person who's involved. This is a person who either has a giant post-it pad or a chalkboard or a computer usually connected to a projector. And that person is a secretary whose basic job is to record every single idea in a way that everybody around the group can actually see those ideas. You don't want to just work on your own personal laptop on your own screen where no one else can see it, because then other people can't say, look at ideas that have been mentioned before and combine them. So make sure that you're writing things up on somewhere where everyone can see. We've got some giant post-it pads right here. And you can grab them, and we've got some markers, stick them up on the wall and write on them. So you want to try to just write down, just report on what people are saying. Don't try to be editorial about it. Don't say good idea, bad idea. That's not your job either. You do want to keep an eye on the time, especially because we're doing this in class and time will run out. So make sure that you actually have enough time to get down those last couple of ideas before we go into our next part of our class, which I think is prototyping. The secretary can participate in the brainstorming. It's sometimes a little bit tough. It's tough to write down and listen to what other people are saying while trying to generate your own ideas. So what you might want to do is split up your brainstorming session into basically two halves. How much time are we giving them for brainstorming? 30 minutes. So split it into like two 15-minute chunks, and either the facilitator and the secretary can switch, or just get two other people to be secretary and facilitator. So the people who were facilitator and secretary can sit down and generate their own, and have the space to generate their own ideas while someone else is taking notes and making sure the process is running. So that's what we're asking you to do. Any questions about brainstorming? Or anything else I've said? Is there a minimum idea of ideas? No. There is. You don't have to say, In fact, that's probably counterproductive. Don't say, oh, we have to hit at least 30 ideas and we're done, because that implies that once you're over 30, you can stop. You don't want to stop. You want to keep generating ideas until you run out of time. And if it takes you, 30 minutes to come up with 2 ideas, that's fine. That's the group. That's what your group was able to come up with. Generally, you want to be generating like a lot, several dozen ideas in a 30-minute session.
We're going to ask you to form groups of 6 people. Grab the people who are nearest you. These groups of 6 are going to do us a favor and everybody stand up. As you form groups, sit down. You've got 3 minutes to form groups.
So we just finished the brainstorming session, and I'd like to get some people's impression about what worked. Did you have some time? Do you need some time to get started? Did people kind of feel it went a little slowly at the beginning and then picked up, or died off halfway? What were some of your thoughts? Yeah.
I think if the sessions were instead of 2-minute sessions, if they were even shorter and broken up with each kind of a mini theme, that would have helped.
Okay.
I felt like I ran out of steam.
Okay, all right. So breaking up even further into smaller chunks, and then okay, sure, that's a good idea. How about the note takers or the facilitators? Yeah.
I think starting with words and themes helped us get just basic concepts out there, and then start combining them rather than jumping into game ideas.
Right, and one of the reasons why we did that was also give you an idea of what's a theme versus what's a mechanic, right? Yeah.
I think it's hard to avoid the scenario of someone writing an idea and then everyone's like, oh, that's cool. Let's talk more about that thing instead of just throwing out completely different ideas.
Right. Oh, so switching to a different idea. Right. Well, that's not necessarily a failure of a process either. But you're right. We're trying to generate quantity, and instead, people are trying to improve the quality of the idea. So yeah, but still, that's a happy problem to have, right? It's a good point. Yeah.
I think for our team, jokes had helped us a lot.
Sure.
At first, the situation was more tense, and then after 1 or 2 stupid ideas, everyone became more casual and starting saying more ideas.
And that's where the throwing out the bad ideas part helps as well. It helps you get into that mood of we can be silly now. Something that might help with the switching gears problem is the act of writing it down to begin with. Of course, is sort of says the idea is on record, and just to make it say you can always say let's get back to that later, because you will get back to it later anyway, and there'll be time for that discussion. Doesn't always work, but it's worth a shot. Cool. Okay. Let's talk a little bit again about Project 1, just as a reminder. There is a theme for Project 1, and that's planning for randomness. You generated a lot of ideas. We didn't do we didn't really overemphasize that constraint right at the beginning of the brainstorm session, because we wanted you to generate tons and tons of ideas. Now you should be looking at that theme and thinking and the ideas that you've generated and figuring out which ones of those kind of match that theme. Now that's sort of the overall constraint. The overall constraint of what we want the players to be doing is planning for randomness. But is it in space? Is it some sort of dice rolling mechanic? Is it some sort of race mechanic, or just a branching decision tree or something like that? That comes into themes and mechanics. So you want to be identifying that as well as part of project Project 1. So what we're going to be asking you right now is that from your brainstorming group, we want you to split into 2 groups. That's your prototyping group for Project 1. You only have to work with this group for 1 week. This is not a long-term commitment. There were 8 brainstorming groups. So basically, we're looking for 16 teams. And so we're encouraging everyone to be in groups of 3. Not only does that mean that we will get the right number of groups, it also means that if somebody falls sick in the next week, your team still has at least 2 people to work on it. So for each group of 3, first of all, you figure out who you're going to work with, and then you choose one item from your list, one of these ideas from your list, keeping in mind those constraints that I just mentioned. And we will be using that idea for the upcoming prototyping workshop, which I will be leading. So once you know what your idea is, you know who you're working with, I will go into the prototyping workshop to tell you what you do next. And the goal will be to then test that idea through the process of prototyping. And if it doesn't work, you're free to choose a different theme, but you still have to stick with your team. Okay? You stick with your team, you can choose a different theme, just to be clear. All right. We have 10 minutes to figure out who you want to work with and what's your initial idea that you want to work with. So go for it.
And your team was 6, right? Cool. She's computer controlled, so it was really voice activated. It just didn't work.
There's a more recent game.
Yep.
How many of you have seen me give this presentation before? Okay. How many of you are thinking, does Philip give this presentation every class? Correct, Arino. I do. So I apologize to everyone who's seen this presentation. Maybe there's 1 or 2 little points in here that you might not have seen before, but for the most part it is the same because it is the fundamental skill that we try to teach in every single game design class because it is basically the first skill that you're going to need to be able to figure out whether an idea works. How many of you have made prototypes in any field, say engineering, software, whatever? All right. Why do you make a prototype?
Because it's cheaper.
Because it's cheaper than making the real thing? Sure. I thought I saw some hands up there. Yeah. It's faster than making a whole thing, yeah. But that kind of goes hand in hand too, right? Time is money.
Making drastic changes is a lot cheaper on paper than with a built system.
Okay, all right. You can sort of figure out what's broken and then and then make changes. It shows the proof of concept. You can show it to other people. Not just prove it to yourself, right?
It's a lot easier to experiment and make changes if necessary when you're not committed to something that you put a lot of work into.
All right, you can try a lot of different ideas, right? It's like I'm not quite sure which way I want to go, so I'm going to try a lot of different alternatives.
It helps you realize major flaws before you kind of start making your own.
Catch the big problems that are going to break your design, yeah? To move from 2D to 3D, you'll make a 2D prototype before sort of taking it into a more complex design. All of those are absolutely true. This is the general sense of why you want to do a prototype at all, right? Is to, get feedback from other people, and you get it early, and you get it cheap, and of course, we talked about making changes early on in the process usually costs less money because you haven't committed anything. You haven't invested a whole lot of resources in something just to have to change it again. If you're not quite sure which direction you want your design to go, you want to be able to have lots of different ideas on the table and actually see how all of them work in one way or another. We talked about how easy it is to be able to change your ideas when you're prototyping, but also it's easier to discard a prototype. It's easier to just say, well, that was a bad idea, because you haven't really spent all that much time on it. And in many ways, that's something you're going to need to do in game design a lot. You're going to pursue some of these ideas that you've already been discussing, and you're going to start prototyping it today. And then you're going to say, well, that was a bad idea, and shove the whole thing off the table into a trash can somewhere and start afresh because you've spent, an hour designing this thing. It's not going to be a whole lot of time, and then you can learn from that process and build something new. So it's a very good mindset to be able to have in early iterations that this thing that you're making it's meant to be informative. It's meant to teach you something about this project that you're working on, but it's also meant to be disposable. It's something that you do not have to make look good, or you don't have to make it last. You don't have to make it perfect. You're just trying to learn something through the process of prototyping. Now, when you're making games, this is what you're trying to figure out. You're trying to find the fun. We've talked about games being a series of interesting choices. And when you're prototyping, what you're trying to do is you're trying to identify what are those few game mechanics that are going to be able to sustain the interest of your players over a significant amount of time. So the nice thing about prototyping, when you're, say, trying to design a computer game using paper materials or something, is that you have to define those mechanics down to the very purest form. So, for instance, I could say, oh, this is going to be a game about space aliens, and you're going to run around shooting, different kinds of weapons, and occasionally throwing grenades and taking cover, and you get to fly ships and drive things around. And it's like, but what I can do when I'm prototyping is that, all right, I'm going to make a game where you come out, take a few pot shots, go undercover, wait for your shields to recharge, throw a grenade, wait for shields to recharge, come out and take a few pot shots. That's basically what game? That's basically Halo. That's a thing that you do every 20 seconds in Halo all the time, and that's really the thing that they have to nail and get absolutely right. So if you're making a prototype, you can identify, oh, this core little loop is the thing that's interesting, and if we can actually get it right and tuned perfectly in a digital game, then we know players are going to do this over and over and over again, and it's going to feel good. So you're trying to find that fun. So you're going to focus on the small handful of choices that a player must make in order to play your prototype. And you model a system with a few basic rules that creates interesting choices for the player. Always ask a question about your game. Make sure it's falsifiable. Anyone heard that term, falsifiable, a falsifiable hypothesis? No? Yeah. What's that mean?
Basically, it means some kind of opinion that can be proven wrong.
Yeah. You could say, well, you said, say the question is that we think the players are going to enjoy making these kinds of decisions. And the answer could be, no, they don't. You want that information. It could be something like, this particular design is going to save time, right? It's going to be less of a cognitive load, or it's going to be easier for players to understand. And it should be that kind of question that you ask when you're making a prototype. Your prototype should be able to be designed in a way where you can sit someone in front of it, play through it, and then tell you yes or no. Was that hypothesis true or not? Now, physical prototyping, paper prototyping, doesn't give you insight into everything that you can achieve in a digital game. It doesn't say, for instance, tell you terribly much about the sensory experience of playing that game, or how feasible a certain feature is going to be. So you don't discover everything through making a prototype. But you do get a lot. Now, the other thing that a few people alluded to is the ability for your prototype to communicate to other people, especially other people on your team. So imagine getting into a room full of developers, all of you are game developers, and you don't know what's in each other's heads right now. You maybe have come down to a certain theme, and all of you have different versions of that game floating in your head somewhere. Now, if you want to be able to sort of explain that to somebody else, it can be near to impossible to communicate that. You can try doing it verbally, you can try writing it down, but all of those methods don't really compare very well to something you can actually sit somebody in front and play. So what you're trying to do is you're trying to give your own team, to start with, something solid to work from. It may not necessarily be, it will almost certainly not be the idea that you're going to end up implementing in the long run. But you're going to start creating some sort of framework for you to then say, well, I didn't like that, I should change that. Or I really like that, and we should try to polish that a little bit. So it's a communication tool, and any kind of game design definitely benefits tremendously from early stages of a physical prototype, because it forces you to think through how your game is going to work. Every little detail about how your rules work, at least. Maybe not how your game looks, maybe not what your input mechanism is, but certainly what are the decisions that you're asking for your player and what are the consequences of those decisions. You have to define them, you have to write them down in rules that your players as well as your design team actually understand. And then they're going to try it out, and you're going to see all kinds of emergent little dynamics pop up when all of these rules are put together that you didn't anticipate and could be really cool or could completely break your game, and you want to find that out. I talked about bringing in testers, and as we keep harping on this class, and again, every single class that I teach, testing is incredibly important. But the nice thing about paper prototyping is that you don't really need special skills. You need third-grade arts and crafts skills, really. Maybe, MIT math, sure. But actual, we're talking about using markers and scissors and kindergarten counters and dice. And the nice thing about it is that if your team gets larger and larger, everyone can still contribute to the paper prototype. You could be an artist, you could be a designer, a producer, a coder, a QA tester, even someone that you've just brought in for a day to play your game can all contribute to this, to the design of your game, because it can give you feedback of, well, what if instead of rolling this dice, I rolled that dice? Or what if the grid was a little bit bigger? What if my pieces were a little bit larger and took up more space, for instance? A paper prototype itself is not just interactive in its play, but it's interactive in the design. You can just like open up the hood of your paper prototype and change a rule. Try doing that do not do that when you're working with code. In the middle of a playtest, do not change your code, for God's sake. But you can do that with a paper prototype. And many times, you might want to do that in the middle of a test. It's like here, you're playing a game, 10 minutes into the game, it's like, oh my God, this game is hurtling downhill into a pit. And you can see it, and the player sees it, and you know there is a problem. You can actually just change a rule. And just says, what if we did this instead? Mid-game, even, and then try it out. It says, oh, that seemed to maybe address the problem. Then start the game from the beginning and see if it actually did. But you can't do that with a paper prototype. Paper prototypes, in particular, are very good at revealing usability problems. The simple issue of a player has a decision, knows what he or she wants to do, and has no idea how to actually execute that. It's like, does that mean I roll first and then move, or do I move first and roll? Which piece do I move? Things like that. Paper prototypes are very, very good at sort of just laying that bare. Your team will see where those problems are as soon as somebody who's not part of your team sits down and tries to play it. Let's see. Now, players do tend to more readily give criticism when they see something that's very clearly incomplete. Very clearly something that you're still working on. And if you've got a hand-drawn cardboard paper prototype in front of them, they know you're right at the beginning of this project. They know that they can tell you something about, I really don't like how this character looks. And it's like, that's fine. We spent 2 minutes drawing that character. We can completely redo that. And they'll tell you that if it feels like you haven't spent a whole lot of time in it. And that's a useful trick, by the way, if you're doing, say, the digital version of your games later on. It can actually be easier to get feedback if you deliberately insert some things that look incomplete. A giant box that says placeholder right there while you're doing your testing, just to get a little bit more feedback from your testers, so they feel, okay, you're still working on this. I can tell you that character looks terrible, and it's like, we spent 3 days on it, but you don't say that. You don't say that in front of them, because you want that feedback. But when they give you feedback, you take everything that they're telling you with a grain of salt. Because in a paper prototype, it's very, very easy for a tester to say, I don't like pieces that are this color. I want pieces that are that color. And it's okay, you could just make the substitution. But what you should do is you should sort of think back a little bit and try to figure out why they're giving you this piece of feedback. They may have a personal preference and they think this is the way how it should be executed. But probably what they're saying is that they have some sort of actual problem with your game. And that's the only solution that they can think of. So for instance, why does this person want to change the color of the pieces that they're moving around? Is it because they are having trouble telling the pieces apart? That may be the real problem. And the solution may not be change the pieces to a different color, maybe change the piece into a completely different shape, stick a little sticker on them. On a computer is going to be different kinds of solutions. Vet every little bit of information that comes into you. People can make suggestions on how you're going to change your design, but it's up to the team to actually provide some sort of unified direction on where you want the game to go. So the feedback is valuable, the solutions they're providing may not be the solutions you want to use. Any questions so far about why we're doing prototyping? Nope. OK. We'll have more questions later. So here are the kinds of tools that you're going to be using. Very large sheets of paper. This is probably the smallest sheet of paper. Well, we're going to be using index cards as well. But this is, a lot of you have seen this before in my other classes as well. This is a square grid on one side, hex grid on another. For spatial games, you can use this. But sometimes it's much better to start with a blank sheet of paper. So don't immediately start designing grid games just because we happen to have sheets of gridded paper. But we do want them to be large so that everyone around the team can actually see what you're working on at the same time, as well as the people playing the game. If you're going to be designing something like a iPad game or something like that, don't use something that's literally the size of the iPad. Use something a little bit larger so that everyone around the table can see what the tester is doing while they're testing your prototype. We use index cards for a lot of different things, writing down rules. You can shuffle them and use them as playing cards. You can record data on them. You know, they're very disposable, more accurately, very recyclable. Please recycle any paper material. Dice, of course. They can be tokens. They can be used to help keep track of stats, but something that I've seen a lot, that students like to use a lot, is like they use two 10-sided dice to keep track of a number between 1 to 0 to 99. That's a really bad idea. One brush of the hand, and that variable is gone, right? You can swap the 10s and the 1s really easily. It's like, was that 91 or 19? I can't remember. So if you want to record variables, just grab an index card and just write down the variable. Whenever the variable changes, cross it out, write a new variable. It's much better for you to use dice either as actual randomizers, or you can use them sometimes as tokens that move around on the board. Let's see, what else? Game bits, pieces from other games, are wonderful, but sometimes a little irritating, because if you took them out of a game box, then you have to put them back into the game box. Otherwise, you've just ruined your copy of the game. So I like using disposable kindergarten counters a lot, because I don't really care about returning exactly the same number I took out. And there's usually less assumption about what a kindergarten counter is supposed to be. You know, is it a number, or is it a person? Whereas if you use game bits, you know, that's kind of person-shaped, meeple-shaped. Post-it glue and notepads. Oh, I don't think we actually have any post-it glue right now. But they're basically glue sticks that don't stick permanently. So you put them on an index card or a piece of paper, and suddenly it becomes a post-it. But what we do have are a lot of post-it notepads, both big ones and small ones. And these are useful for you to sort of like simulate displays, for instance, or variables and information that a player is supposed to have, and you don't want it to go flying off if somebody sneezes. Of course, right, I have a picture of some kindergarten counters up there. Pencils, pens, markers, scissors, tape, just to be able to hold things together, write down information. Something else about kindergarten counters. We have a particular kind of kindergarten counter, which is an interlocking cube. Do you take it up?
Every year.
Well, it's possible that we took them out because they're very problematic. Because once I give you interlocking cubes, you make games about interlocking cubes. It's like handing people like Legos, and then the first thing everyone thinks of is, let's make a game where you put things together and assemble them. It's like stacking counters.
So you make games about
stacking. Yeah. The pieces that you end up prototyping with sometimes ends up shaping the direction of your game. And sometimes, if you are dealing with a designer's block, you know, that can be helpful. That gives you a path to follow. But in many ways, that's a distraction. You start becoming constrained by your tools instead of the idea that you're trying to work with. So if we manage to get rid of the interlocking cubes, that's awesome. But if they're still in there, by all means use them. But don't try to don't automatically assume you have to make a game about interlocking cubes. Now, don't forget to keep a record of everything, including all of the notes that you've had. Use your phone camera during the session. at the end of your project, make sure that you try to get them scanned or photocopied in some way. There are a lot of photocopy machines around campus now. There are actually scanners, and you just put the materials on top, and then instead of generating a copy, you can have them email a color scan to your email account. Those things are really useful for your final assignment. Okay, so those are the tools. Who are the people sitting around the table? When you've actually made a prototype, then what happens is, I guess I got some of my slides mixed up. This usually happens at the end of having designed a workable prototype, is that there's going to be a bunch of people sitting around the table, and each person has a different role. That's of course the person who's actually going to be playing the game, preferably somebody from a different team or somebody who's even outside of this class. It could be one of us instructors, for instance. It could be one of the OCW people. And somebody in your team is going to be a facilitator. This is the person who's going to present the rules to the person who's going to play. Tell them that we're looking for your feedback, make them comfortable, make sure that they understand what they're supposed to be doing, and basically making sure that the session runs according to script. That person or somebody else can also be the computer. And this is the person who is actually making the prototype work, updating variables, moving the positions of pieces on the board, revealing new dialog boxes, or again, basically making the board respond to what the player decides to do. And the computer is trying to do all the computation that your actual computer will do if you're making a digital game. The computer should not do anything that a real computer wouldn't. So for instance, if somebody doesn't understand a rule, the computer person shouldn't be correcting the player. The facilitator could, but sometimes what I find is really interesting is that somebody thinks a rule works differently. I let them play through it, and that becomes like a different iteration of the game, and sometimes it turns out to be better. Then you can run through the iteration with the corrected rule. Yeah.
So the person who's the computer does have to make a choice at that point of whether they were let them play according to what they think the rule is.
Yes.
Or what the computer, if it were a real computer, it would
Yep.
just they do something that doesn't work, they would just ban.
And the person playing the computer says, nothing happens. It's like, you can do that, right? It's like if the person really doesn't understand the rule. But if the person, if you notice, say, this person is clearly playing a really suboptimal strategy, just respond like a computer will, lead them to that lose condition or whatever it is that happens. Because in many ways, that's how an actual player is going to learn how to play your game in the long run. They're going to make a lot of bad decisions. The computer is going to respond, and then they're going to learn from the mistakes that they made and then try it differently. Let's see. Something else that the facilitator can do while the game is going on, say the player is actually playing, is to encourage the player to think aloud. So the person that you brought in to play your game is trying to understand your game, and they're just sitting there in silence looking at the board. And you don't know if they're bored, confused, or really into it. So you ask them, what are you thinking now, right? And if they're saying what are all these pieces? All right, then you know that they're confused. The facilitator can help. Can say, all right, let's start again, and I'll explain what all these pieces are. It could be, I've got 5 different strategies, and I'm trying to figure out which, I'm thinking maybe if I move this here, move this there, okay, that person's into it, right? The person's really thinking hard about this problem. Everybody else in your team watching that board, and this is the reason why we have a big board, is an observer. You want to be able to see what's going on in your game. You want to be able to write down information in a notebook or on your laptop and try to record whatever information. Most importantly, look at the face of the person who's playing the game. See, again, that helps identify whether they're confused or whether they're really into it, they're trying to make a tough decision, or they're just bored. Don't offer help to the user, especially if you're on a development team and you know all about this game. It can be a real temptation to be able to basically just tell the user, this is what you want to do. Don't do that. Sit on your hands, bite your tongue. It can be hard to take notes when you're sitting on your hands, but take notes. the person who's being the computer and being the facilitator really doesn't have the bandwidth. Those people do not have the bandwidth to take notes. So someone has to be officially designated with the job of actually taking notes and observing. What we're going to be doing is a Wizard of Oz test for your games, and that is someone's playing the computer. It's very constrained in terms of communication between the computer and the person who's testing your game. The rules are usually pretty rigid, and the nice thing about it is that you can do a pretty deep analysis of your game. You can make a game that sort of goes through multiple decisions into sort of long-term consequences. That's not necessarily what we're asking you to do for Project 1. I'm just telling you this because you might want to do this for Project 2, 3, or 4. A Wizard of Oz test allows you to really do a deep dive into how a particular feature works, for instance. Since it's a human simulating the backend, simulating the computing, you can be very high fidelity at very little cost. That's not, again, we're asking you to do for Project 1. We're asking you to do a low fidelity prototype, and we'll go in a little bit more detail about what that is. Very important, don't let the player know what the computer is thinking. The computer only displays information. You do not reveal how the computer is coming to those conclusions. There are a couple of other kinds of prototypes that you could design. I'm going to run through them very quickly because that's not what happens in this class. Player versus player, what you'd expect in a board game or a card game situation. We have a class just for that. And you can make cooperative games, competitive games. You can make games where everybody has the same role, a symmetric game or asymmetric game where everyone has different roles. The problem about that is that there's a lot of loose communication happening between the people who are actually playing your game. And they may decide on a house rule that was totally not what you intended or designed as developers. And that turns out to be the rule that they'll end up playing with. Again, what I like to do is I like to see them play through that rule. Then at the end of the game, I correct them and I have them play through the rule that I originally designed, because sometimes the rule that they came up with is better. The facilitator, again, helps to explain the rules at the beginning of the game, and then you kind of just watch after that. It's hard to get consistent results across tests when you're doing a multiplayer game because it's very hard to sort of duplicate exactly the same situation, whereas you can do that on the Wizard of Oz test pretty easily. But if you're making a multiplayer game, you have to do a multiplayer test. So this might actually happen. Actually, are we saying that you can only do single-player games this semester? Or I'm not quite sure what the constraint is. You can also do live action, not for today, but I actually enjoy these, where you actually have predetermined rules that are explained between the game, and then you just let real human beings walk around and do stuff. The problem with this is there's a very limited communication between people who are playing the game or even the people who are running the game, because everyone's kind of physically spread out. But it can be fun it can be really useful for a game if your game is really about a human being walking through a space. Such like a stealth game or something like that. Yes, there's actually a person in that U-Haul box. All right, so when you're actually making your prototype, here are the things that you have to make sure you do for every single prototype. Keep it hand-drawn, because hand-drawing is fast. You want to keep it really, really sketchy and look really sketchy and rough, again, because that actually gets you feedback from the people who are testing. If you make it look too pretty, people are going to hesitate on commenting on how your game looks, for instance. They may actually hesitate at commenting how your game works, even though that may not be the prettiest part of your game, because they can tell you spent a lot of time on this game. Again, you want it to be big. Everyone needs to be able to see what's going on during testing. And just use one dark color if you can for your inks, for your markers. It needs to be dark, high contrast, so that everyone can read it easily. You can use different color cards, for instance, to be able to tell this card is a different kind of card from that card. But don't use multiple colors on the same card. That's just not worth the effort. And again, it gives people the impression that you spent a lot of time on this prototype. And even if you have, you don't want to give them that impression. You write your rules on the cards, so keep track of your rules. Eventually, you're going to end up like typing it down on your laptop because that'll make it easier for you to turn in your work for project 1. But while you're working on a prototype, try writing your rules on the cards instead, because that allows you to do things like rearrange the steps in which certain rules operate. It allows you to change out a rule really easily while keeping the old rule around, and you can just swap things in and you can try things differently. Every time you change a rule, change the card. If you're changing a number of rules, like instead of take 3 steps every turn, you say take 2 steps every turn. Just cross out the 3 and write 2 in there. Periodically take photos with your phone cameras, and always try to simplify. Always try to get down to the smallest set of rules that is necessary for you to test your idea. Part of that is just a speed up testing. You're going to test within your team first, just to be able to see whether this basic mechanism works, and then eventually you're going to end up testing with each other. And the simpler your rules, the less time it is to be able to start a new playtest, because there's less for you to explain to somebody else who's never seen your game before. So try to get your rules to be as simple as possible. Also, if you have too many rules and something breaks in your game, it's sometimes harder to figure out which rule was the culprit. If you have fewer rules, it's usually more obvious for you to spot. Now, we talked about iterative design a lot, and this is basically the loop that we're using while we are paper prototyping. You start with a question, a falsifiable question, a yes/no question, and what is this prototype going to achieve? Maybe in this particular case, it's going to be, does this theme that we picked actually have randomness in it that you can plan for? Or is the randomness so random to the point where you can't plan for it? Or is it really just very deterministic, and then when you play the game, you can really tell, yeah, here's the optimal solution. You can look at axiomatic design. Anyone heard of this term? Mackey in particular uses this a lot. Which is basically, you establish axioms, which are things that you are taking to be true or baseline, that need to be fulfilled by any workable design. So it could be, we assume that this game needs to have some sort of random condition that's generated that changes during the game. And we need to be the player to identify that this number is changing and anticipate where that number might end up going. And if your prototype fulfills both of them, then you know that prototype worked. And you can build a lot of different prototypes that fulfill those same 2 conditions. That's another way to sort of start with a question. And then you actually start designing, grabbing those pieces of paper, writing out your rules on cards, brainstorming on what your game's all about. But you want to do this as quickly as possible. The less time you can spend talking about this, the more different kinds of ideas you're going to be able to run through, and that's what we're trying to go to do during a prototyping process. If you're ever in a situation where you've got 2 different options, this might be better or this might be better, and you're not quite sure, it's usually faster in paper prototyping to just start making both prototypes. All right, you do this version, generate the cards, play through both of them, and you'll get actual evidence, actual play testing evidence on which idea seems to work better. After you design, you play through it. First within your team, and then you grab somebody from some other team or one of the instructors, and we'll sit down and we'll play a game to see where are the strengths in this design, where are the weaknesses. Whatever you design within an hour is going to be clunky and broken and really, really, not quite where you want to be. That's fine. Go do a play test with that expectation that there are going to be problems. And you'll get a lot more information out of that play test than you will working on your own. And then you'd use that information to revise your design. Make changes, and then you repeat this entire process again. Either you amplify it on the strengths, you figure out what your weaknesses are, and you make big changes. So you repeat that. And here are a couple of tricks that can work sometimes if you have trouble figuring out what sort of changes to make in your design. Killing a rule, just like taking a rule out, sometimes fixes problems more than trying to fix a rule itself. A certain thing is bogging down the game. A certain thing is too confusing. Does the game work if you just take that rule out? Sometimes it does. You can make a resource that's limited, unlimited, or make an unlimited resource limited, limited health, unlimited health, limited ammunition, money. Player interference is more for multiplayer games where sometimes if everybody is playing their own little solo game and they're not interacting with each other, you come up with ways to mess up each other's plans. That doesn't always apply with single player games, but if you've ever played a game, like a role-playing game where you can delay an enemy. Has anyone seen one of those? Where you can like cast slow or something on an enemy and they can't attack you for another turn or something. That's player interference, right? Only the player that you're interfering with happens to be the computer. And what can you do to basically get into somebody else's plan and change it? And the computer can have those rules too. Mess with the play order, mess with the order of your rules. Just try rearranging the order of rules, and sometimes by grouping things into sort of logical chunks, you can make the game easier to understand. Instead of saying, first you decide whether you're going to do this, then you decide whether you're going to do this, then you're going to decide whether to do this. Maybe you just say, make 2 of these 3 decisions, right? And every turn you get 2 of these 3. Make them in any order you want. That's a way that you mess with the play order. If you're going to change variables, either multiply or divide them by 2. There is not enough granularity in the prototypes that you're making today to do like a 10% change in a certain variable and then be able to detect whether that change was the right change or not. That's not going to be obvious enough. Do like big multiples of 2, of 3, to be able to see whether that's the change that's necessary. You can tune things later when you are preparing the project for the playtest on Wednesday, for instance. But when you're in this class, do things by big multiples. If your game's really kind of getting bogged down and taking too long to play, try to get down to the core set of rules, the minimum set of rules that's necessarily even just for your game to work. Just for the game to run at all, try to figure out what that core is, the minimum set of rules, and then add in each rule one by one. Reconstruct your game. That's one way to identify where the main problems are in your game, because as you add the problematic rule, things start to break. And finally, be willing to just throw away everything that you generate in the next hour. Okay, anything that you make in the next hour might in fact just be terrible, and you're going to learn that, and that's fine. That's why we make prototypes, so that they can be disposable. That's how I started this talk. So any questions before we actually start making stuff? Coming up with rules, you're going to grab pieces and create some sort of play surface or cards that people are going to play with. You don't need to put anything on the board. Before everybody runs down and grabs things, I guess we're going to go back and remind people what a low-fidelity prototype is.
Terrible as long as you're aware of it. I thought I replaced them with the stacking counters, but I guess I didn't. All right, so we just have a couple more minutes left of class. Couple things to remember before you leave. Take pictures of all of your brainstorming notes and keep your notes with you, so take them away with you. Make sure everyone on your team can access those notes. Make sure you know the email addresses of the people you're on your team with, so you can talk to them again. And before you leave the classroom today, start up a document and enter your changelog. So put in what you designed today and what problems you found by the end of the day. So I'm going to repeat that one last time. Before you leave class today, start up a document, open up and start up your new design changelog. Put the date, put what you did today, so a brief two or three sentence description of what you designed today, And what are the problems you're facing now? That'll be important to you both for when you meet as a team again to remember what you did, but also later on to have a full history of everything that you've done. Okay? One more thing, yes?
One more thing. Tomorrow,
Wednesday.
Rather, we are going to have play tests. We're going to be play testing all the prototypes. So you need a playable prototype for Wednesday. Bring it to class.
And then we're starting Wednesday's class off with discussions about the game engine tutorial. So bring your problems, bring your questions about the engines that you were assigned, and we'll talk about them. All right, see you Wednesday.